Modern agriculture requires an immense supply of synthetic nitrogen fertilizer to function, and nearly all of that nitrogen is currently extracted using natural gas. This image of empty freezer shelves shows what happens when those industrial logistics fracture. When the flow of chemicals stops, the local ability to produce food is immediately compromised. To defend against a chemical shortage, you must generate your own biological fertility on site. You have to build humus. Humus acts as a biological sponge. It physically binds soil particles together, allowing the ground to trap water instead of letting it run off. Transitioning to self-generated humus is a foundational step toward making a production system less vulnerable to the erratic flow of industrial supply chains. Our objective here is to construct a highly aerated, quick compost pile. By managing the airflow, we can produce usable material in just 1 month. You will need 4 specific inputs to make this work: dry carbon, like leaves or sticks, green nitrogen from weeds or scraps, raw livestock manure, and native soil. We are implementing a closed nutrient loop. This turns local waste liabilities into high-value plant food that stays on your land. Step 1 is the ground setup. Drive a sturdy 5 to 6 foot wooden pole completely upright into the center of your designated composting area. Around this central pole, lay down a base layer consisting entirely of thin sticks and branches. This creates a porous foundation, allowing oxygen to flow underneath and begin drafting up the central shaft. The biological breakdown in this pile acts like a slow fire. It requires a constant supply of oxygen from that central chimney to keep the microbes active. Without that aeration core, the pile suffocates. Instead of life-giving fertilizer, it becomes a toxic, anaerobic rotting mass. With the core established, we begin the layering protocol. The materials must be stacked systematically, alternating in specific strata like a lasagna. This diagram shows the correct order. The first tier requires a 6-inch foundation of weeds and dry biomass. Next, apply a thin layer of fresh manure to add nitrogen. Cap the organics with 2 inches of native soil, inoculating the pile with bacteria. Make sure the soil layer completely conceals the materials underneath it. This seal is necessary to trap heat and prevent odors from escaping. As the pile grows, use the wiggle technique. Every time you add about 15 inches of height, grab the center pole and shift it vigorously side to side to keep the chimney open. This repeating sequence balances the nitrogen-rich manure with the carbon-heavy biomass, while the manual aeration ensures the pile continues to breathe even as it grows heavy. Once the pile reaches 3 to 4 feet in height, complete the structure by pulling the center pole straight up and completely out of the pile. The top edge of this diagram illustrates the final step of the setup. Pour water laced with effective microorganisms directly over the top and down that open central shaft. Check the moisture by squeezing a handful of the material. It should feel damp, like a wrung-out sponge, never dripping wet. This solid compost will take a month to cure, but if you have struggling crops right now, they may need immediate nutrient support. For immediate needs, use a liquid fertilizer triage method. Steep green weeds and a single handful of manure in a covered drum of water. Use the liquid while the biological activity is at its peak. If you wait until the materials are completely broken down, you lose the immediate fast-acting benefits and will have to restart the process. Integrating long-term humus generation with rapid liquid triage provides a multi-speed approach to maintaining soil fertility. Returning to your main compost pile, there is only one final maintenance step. After 2 weeks of cooking, turn the steaming pile exactly once to mix the outer layers into the hot center. 2 weeks later, the material is dark and crumbly. The breakdown process is complete, leaving you with the soil-like texture of finished humus. True independence is only achieved when a location stops importing external chemical fertilizers and starts cycling its own biological wealth. Start gathering your materials and build your pile today. For more survival protocols, subscribe to the Earthway Bunker.